This is MA 104, Section 2.2, numbers 43 to 51 odd. We're asked to find the center and the radius of the circle with the given equation. If we recall, the equation of a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. This tells us that the center can be found by looking at whatever is being subtracted from the x and from the y. In the case of this equation that we're given, the x is by itself. We can actually think of this as x minus 0 quantity squared. Instead of just x squared, we can say x minus 0 squared plus y plus 2 squared equals, instead of 9, we can think about 9 as being 3 squared, because the square root of 9 is equal to 3. This tells us that the center is whatever is with the x and the y. We take the opposite. Well, the opposite of 0 is just 0. 0 doesn't really have an opposite. And because the y has a plus 2, the opposite of that would be negative 2. The radius then is what's being squared. That would be 3. This one's already set up in that standard form. We want to look at the opposite of what's with the x and the y to get the center. So the center of this particular circle would be negative 4, positive 2, because we are subtracting a negative 4 to get plus 4. We are subtracting a positive 2 to get minus 2. The radius then is the square root of the number that's by itself, the square root of the constant. In this case, the radius is just the square root of 7. In this particular example, I have to condense the x terms to be some quantity squared. We can accomplish that by using that technique of completing the square. So I have the x squared plus 6x. To complete the square, I have to take half of the 6, which is 3, and square that to get 9. Again, half of 6 is 3, 3 squared is 9, so I will add 9 to that amount. I still have the plus y squared equals 16, but because I added 9 to the left side of the equation, I also have to add 9 to the right. The x squared plus 6x plus 9 is now a perfect square trinomial. I can write that as x plus 3 squared plus, and then the y squared I can think of as y plus 0 squared equals 16 plus 9 is 25. If you need a refresher about how to complete the square, please go back to the videos from Chapter 1 and review the section on quadratics. In this case, the x squared plus 6x plus 9 condensed to that x plus 3, so we used that completing the square. That tells me that for the center, the x coordinate is the opposite of what's with the x. Since there's a plus 3 with the x, the opposite of that is minus 3. And then the y coordinate is what's with the y, and 0 would be with the y. The radius then is the square root of the constant term over here. So the radius of, the square root of 25 is just 5. In this example, we're going to have to complete the square twice, once for the x terms and once for the y terms. To accomplish that, I'm going to commute the y squared and the minus 6y. This will get the x terms together and the y terms together. So instead of saying x squared plus y squared, I'll say x squared minus 6x, and then I'll have the plus y squared minus 4y equals 36. By putting the x's together, that allows me to look at the x squared minus 6x and determine that the number I have to add to complete the square is going to be 9. I have the x squared minus 6x. The way that I got the 9 was to take half of the 6, which is 3, square that, which is plus 9. So I can add 9. Then I have the plus y squared minus 4y. And again, to add on to complete the square, half of 4 is 2, 2 squared is 4, so I will be adding 4. That equals 36, but whatever I add to the left, I have to also add to the right to keep it balanced. So I will add the 9 and add the 4. The x squared minus 6x plus 9 now factors into x minus 3 quantity squared, plus the y squared minus 4y plus 4 also factors into y minus 2 quantity squared, equals 36 plus 9 plus 4 is 49. This is now in standard form for a circle. I can get the center by looking at what is with the x and the y. So my center would be the point 3, 2. The radius is the square root of the constant, so the square root of 49 is just 7. Finally, to be able to place the equation of this circle in standard form so that I can find the center and the radius, there's a couple different things that I need to do that I didn't have to do before. First, I have to clear these coefficients. I have to clear these 3's. I have to have the x squared and the y squared with coefficients of 1. In other words, they have to be by themselves. So the way I'm going to accomplish this is to divide everything by 3. Every term gets divided by 3, technically including the 0, so that I'm left with x squared plus y squared plus 8x minus 6y plus 8 equals 0. The other thing that I want to do is move some terms around. I want to commute the terms. I want to move the 8 to the other side of the equal sign, so that will mean subtracting 8 from both sides. And then I also want to switch the y squared and the 8x terms. That way I'll have all my x terms together and all my y terms together. So we'll do those couple things in the same step here, which gives us x squared plus 8x plus y squared minus 6y equals negative 8. So all I really did there was switch the 8x and the y squared, and also I subtracted the 8 from both sides. Now I can figure out what I need to add to complete the square. To the x's, I have x squared plus 8x. I need to add something by taking half of the 8 and squaring it. Well, half of 8 is 4, and 4 squared is 16. So I'll add 16. Then I have plus y squared minus 6y. Half of 6 is 3. 3 squared is 9, so I'll add 9. Equals, I had the negative 8, and then I also have to add the same 16 and 9 that I did to the left side. To complete the square then, I can see that x squared plus 8x plus 16 will factor into x plus 4 quantity squared, plus the y squared minus 6y plus 9 will factor into y minus 3 quantity squared, equals negative 8 plus 16 plus 9 is 17. This equation is in standard form. Let's do this up here. So I can find the center and the radius rather quickly. The center is the coordinates of the center are the numbers that are with the x and the y. They're the opposites. So that will be negative 4 and positive 3. And then my radius is the square root of the constant. So the radius in this case is the square root of 17.